I feel great. I feel less jet lagged than I was 2 days ago, but I'm very excited to be here. I'm excited to attend the sessions today. I'm going to attend Aaron's session on RLHF. I highly recommend. It's a very important piece in today's technology, and yeah. But actually, John, I have a question for you.
Me?
Are you sure that you only heard about the paper 3 months ago? Yeah, that paper is very popular. You probably should have heard about it much earlier.
Sorry for that.
Sorry. You talked about my hair. I had to do something in exchange. Yes.
What I know is that I'm actually one of my friends sitting there. He said he's like a legend in this area. So what? He said the transformer, Google transformer, is really it's like a base, and I brought the paper by Forbes. Forbes article said that's undisputed gold standard for AI technology today, transformers. What you have done?
Right. So I didn't. How do I describe how I'm? I guess I'm going to try to describe how I'm feeling, and I'm going to describe some of the journey as well. It's both excitement, right? Like TikTok influencers are using 챗GPT, which use the transformer, so that is surprising. There's also some parts that are not surprising. I'll explain why. Some parts that are disappointing, and some parts concerned and scared as well. But first, I guess the excitement. You're correct that the transformer has now become a technology. Most people using the transformer today are likely not researchers, which was the case. The project started with Jakub Ilya Pulusukin, who also actually has a crypto company. He left very early on, and Ilya Pulusukin and I built the first models. My co-founder Nikki joined the project, and of course then Noam joined the project as well later on. So it was like a progression of people and ideas that finally led to that architecture, right? But what's interesting is how over the years the broad adoption of the transformer is indeed surprising. I was trying to think, is it like a where have you seen that before? And airplanes are interesting. So we don't completely understand the principles of flight, but we were able to make aircrafts that fly. But we really trust our airplanes. We really trust them, right? It's funny that we're using, that's the part that's surprising, that we don't completely understand the transformer, or we don't really fully understand deep neural networks in general. But the broad impact has been pleasantly surprising. At the same time, it is recorded. I have shared myself that it's funny. Google Brain is in Mountain View, and I lived in the city, so it's like about 40 miles away. And I was sleeping on a couch in the Brain office at night, writing the paper. And Aiden was there. He was asking me. He thought that this would only apply to machine translation. I told him no. The impact is going to go much farther. But even I was surprised. I foresaw many of the applications. I myself worked on protein folding. I worked on image generation, and I worked on music and biology as well. But the adoption has been very surprising. I think the part that I'm perhaps disappointed from a research perspective is I don't think people here actually know why we even started the transformer. So are people here aware of diffusion models? Diffusion models, right? You generate images. So one beauty about diffusion models is that they iteratively they generate something and then they fix it. They keep improving it, right? And that's actually what we originally wanted to do with the transformer. We wanted to generate, like we wanted to do translation. So you have a German sentence, you produce words, and then you iterate. But we haven't still fixed that. So I think it's been overall just a exciting journey. Yeah.
Where the name came from?
Oh, it was Jakub that originally said, hey, we should call it the transformer, but basically, it comes from the work that the transformer does is it takes music, or it takes a sentence, it turns it into a bunch of vectors, and then it actually transforms it again and again and again until it then produces the final output. So it's both a cool name, but it also kind of relates to the mechanism. Yeah.
Here it says that that's Beatles song "All You Need Is Love."
Oh, you're talking about the name of the song, yeah. So the story goes, we wanted that's somebody who's a Britisher, Leon, who worked, who was there present. He said he's a Britisher, and he said, all you need is love, and then we modified it to attention is all you need, and that was a mistake. Now there's like thousands of papers that say dash is all you need, and like hype is all you need, or one layer is all you need. Yeah.
By the way, what is AI in your definition or in your life?
That's okay. So I think the definition. You know what? I think the definition of AI has stayed pretty constant. The term artificial intelligence was coined in the Dartmouth conference in the 50s, and people wanted to build machines that could read language, learn by themselves, and I think to a certain extent the definition has still stayed the same. We still want to create machines that can learn by themselves, they can talk to humans, they can think, and we've got the Turing test is often used as I guess the Turing test is not the most effective mechanism for identifying intelligence, but in some ways the definition hasn't changed much. With the broad adoption of AI, the transformer and AI becoming a technology now, I think the definition is probably more commercial. That is, models that can perform the tasks, the economically valuable tasks that any human can perform, is a good working practical definition of AI. That's how I see it.
Good. Today we have a session by Hugging Face.
Oh yeah, that's right.
We have a session by Stable AI. We have all these applications, companies, tools, softwares, transformers, based on transformers. And you see that emergence, fast, explosive, phenomena of generative AI. You are looking at all these milestones of generative AI. How do you feel?
I think, again, I think because the transformer is so general, it's not surprising that it's applied in so many. It has improved the state of the art, and that has been the ultimate mission in some sense of deep learning. That you don't have to add a lot of human biases. You automatically learn rules from data. So I think we've kind of accomplished that. We've made great progress in that mission. But I will say, perhaps the most surprising piece is that unsupervised learning works. Yeah, we set out in Aaron, you probably we set out in 2006. Geoff and the other sort of the scholars that have been working on neural networks for a while. They wanted to make unsupervised learning work, and can you believe it? It actually works, and it was simple. You take large amount of data, large amount of compute, you take a transformer and language modeling, and now we have models that can think that can reason like humans, they have tremendous amount of knowledge, they can plan a bit like humans, and I think we can comfortably say that unsupervised learning has been solved, and that's probably what has surprised me and that excites me the most, that we've made so much progress with simple techniques, and what the dream that we set forth has been accomplished to some degree.
Good. On the other hand, there was a huge shortage of computing, semiconductor chips. You made the NVIDIA very profitable.
I'm gonna tell Jensen that to give us some free chips. Yeah.
How do you forecast the shortage of the computing chips? I mean, the cost is rising.
Yeah.
So
yeah.
some more companies cannot cover that.
You're right.
What is your opinion on this?
That's a good question. I was reading that I think this year alone there'll be 550,000 H100s I think that are going out this year itself. That's a staggering number. I was also checking how many words would that generate in a year, and it's not as much as the internet, but you could generate a lot of tokens if all of them were using like a 60 billion parameter transformer. So in a second, you could probably generate billions of words with that. So it's kind of funny. Like we might be able to generate a book for every human in the world or something like that. With if you put all of them on inference, I think that what's interesting is a lot of this compute today, to the best of my knowledge, is being used to train these systems, to train them. At some point of time, actually deploying them and putting them in people's hands is going to be where a lot of the value is going to come from, and that also means we will. So I think it is exciting that even though we're deploying a lot of compute, the unit economics of intelligence is improving. Every year, the intelligence per dollar is increasing. Like today's 16 billion parameter model is as good as last year's 32 billion parameter model, and because of many advancements in data, actually, right? Yeah, and so that piece is exciting. I hope that most GPUs will actually be dedicated to inference in the future, not just training. And what it means for startups is indeed challenging, but what's interesting is some with open source in particular, some companies are now taking the responsibility to training intelligent models and releasing it so that people don't have to do the work, and that's kind of so now they're eating up the cost so other people don't have to train their models. So I think that there's some balancing, but I expect I think that there are other companies as well that are now going to put out their chips. So I expect the cost of intelligence per dollar to decrease, and then us to see. I hope that we'll see more inference applications. Yeah.
Thank you. All right, good. Erin? Actually,
Hi.
yeah, please introduce yourself.
Hi everyone. 안녕하세요. My name is Erin, and I'm a founder of Eval AI. Yeah, previously I worked at Scale AI and Microsoft. Nice to meet you. 만나서 반갑습니다.
Actually, the Erin studied in Stanford, is it?
I studied at Columbia University
Sorry.
on the East Coast.
And then she worked for Microsoft, and then she worked for Scale AI, and then now she's starting her own business. So I invited to Erin to this stage. Please continue.
I'm honored to be here. 초대해 주셔서 감사합니다. So John covered the compute part.
Yeah.
In order for us to achieve AGI, Ashish, it is one is compute, and the other is data. And you mentioned a very interesting point which is unsupervised learning.
Yes.
But what we are witnessing since last year, the enormous success from ChatGPT, it is actually reverting very much back to supervised learning, from what I understand.
That is correct,
using
yes.
instruction data.
Right.
They put a lot of effort to actually charting those instruction data. And I'd like to hear about what other format of training data would you like to see in order for transformer or other unsupervised models to be actually very useful to the downstream task.
This is a good question. Even though we're generalizing, like we see so many general capabilities, I like to call it brute force generalization.
Exactly.
Because you're eating up billions and trillions of tokens, and you're also then subsequently using a lot of specialized annotated data. So it's kind of like brute force generalization, but still we haven't seen that work before. So it is quite exciting. Were you going to say something?
I was going to say so GPT-3. Was 175 billion parameters.
Right.
But the tokens
Correct.
was only 300 billion tokens.
Correct. It was starved of data. Yeah.
Right. And then what's interesting, the Instruct GPT, the backbone of the ChatGPT, is only 1.7 billion parameters, and they haven't released the data, so we don't know how much data that they consumed. And they showed it on a graph. The distinct improvement from those instruction data while only using 1/100th of parameters. So I'm just curious to hear, because you're a pioneer of the large language model training, what other training data format you would like to see?
So one interesting fact, the largest model in the Transformer paper was trained on English, French, and it was 213 million parameters, I believe, and we had about 1.5 billion tokens. So I was actually looking in the chinchilla laws, and the recommended number of tokens is 5 billion, and we train on about 1.5 billion tokens. So not very far off, but yeah, I think that. So what are the statistics? There was a paper that says that we're going to run out of tokens by around 2030. There's huge error bars there. I mean, of course, then there's multimodal data, right? So much knowledge. And so much knowledge is on YouTube, and knowledge of a very interesting kind. There's so many videos of people using CAD, people using software. I mean, I think that it would be incredibly promising if we can have a model that just kind of watches YouTube and you can use it to then learn how to use software by just looking at a computer screen, right? So there's many more modalities of data. You know, there's data, but I think that one piece of data that we're actually missing here is data within the enterprises, right? All that dark data that these models don't have access to, that's going to ultimately help us unlock a tremendous amount of value for companies. And what essential and what I'm very excited about is how can we take this knowledge inside the enterprise and make it accessible to everyone so that they can make better decisions, right? Structured data, unstructured data, documents, PowerPoint slides. I think so. I do expect, you know, and as you very well know, it's not just the amount of data, but it's cleaning. Every year we're finding that if you clean data better, then you can actually get to the same performance with better data, right? So if you ask me, I expect like maybe 2x improvements from data, and I think that's still quite promising. But the key is going to be answering the question, how much of this existing open source data can you generalize for applications in the enterprise, and then how can you actually quickly adapt, or how can you then help enterprises leverage their own data, like for personalization, for coding standards, or for analytics, and that's the important question to ask. That's what keeps me awake. Yeah.
Is that what Essential AI will be?
Yeah, exactly. Our mission is to help companies extract any actionable, any important knowledge that they have in their data, like structured and unstructured data, so that they can answer business questions. Like, it's surprising that the people today in companies are you know, we've talked to many users, and they're actually less informed than they were, because data is increasing, but their ability to extract knowledge from it is not keeping up. And how many customers do I have is apparently a tough question, or when am I going to meet my revenue targets, or how are customers using my product? So there's tons of questions, and you know, today, if I told you that in the future everybody's going to be a software engineer, you would not be surprised, because there's ChatGPT and Copilot. But we want everybody to be able to be a decision maker, a data-driven decision maker inside the enterprise. And I think we're going to make it possible. Yeah.
Thank you for your insight.
Well done.
I think so.
Okay, good. All right. Sorry, Korean. 질문 주신 분 네네네, 좋습니다. 오케이, 굿. 우리 스텝 있으세요? 좋습니다. 네. 다음 10분 정도는 질의응답을 받아볼게요.
Hello, and I have just one simple question. How do you think about Hessian metrics to calculate interaction between model and data? Because I think ResNet and Transformer is very significant model, and I think nowadays we should think about Hessian metrics for researchers. Thank you.
So when you say the question, when you say Hessian matrix, you mean using second order? Like, we're already using second order information, like Adam and other methods use it, right? I think that the challenge is, how do you even calculate the Hessian, right? There's just computational challenges there. So I'm not an optimization expert, but if I will state an important problem that I think hasn't been solved, and maybe that's related to what you're asking. identifying what data we should actually update the model on is a very important question. And if that's what you're asking, I believe that needs to be answered, because it's entirely possible that some updates actually worsen the model and some updates are not necessary. So how can you make your flops very, very useful by quickly identifying whether you should be updating on some examples or not? And we're seeing some instances of this research work out, but I think there's a lot of important work to be done here. If that's what you're asking, then I think that's an important research problem, yes.
Adding my 2 cents, if your question is about why we are not using second-order derivative for optimizer, actually they tried, because if you use Atom, is a lot faster than using second-order derivative. So they saw, but there's always trade-off, right? If you calculate very accurate second-order derivative and make the one step very accurately, but then there's a lot more compute. So I believe there are many papers out there comparing how there are people who wants to push the second order derivative as famous as Atom. So, but in industry, it doesn't look like it's meaningful enough to put that much effort in computing.
네, 또 질문 받아볼까요? 네, 네, 저쪽에 중간에.
Hi, thank you very much for sharing your ideas. I have a very simple question. Do you think that there will be another transformer-like model, completely different models that concord the large language models like the transformer nowadays?
So to answer that question, I mean, it's hard to answer that question with certainty, but it's helpful to look at the transformer and what pieces it actually combines, right? So it uses attention, which actually is a very, very old concept. In one of the vision papers, we described mechanisms like attention that were being used in computer vision called non-local means, right? Convolution is an extremely old concept that also takes some inspiration from the human brain. So I do think that there are some, like, I do think that, and there's some other advantages to both dot product self-attention and convolutions. They run really fast on GPUs and modern accelerators, right? So that's extremely important if you want to train models faster. And there are other parts of the architecture or also make it, like, sometimes I like to joke that all we're really doing is building better architectures so that stochastic gradient descent can optimize them, right? So there's many constraints. Essentially, the world of architectures is like you're operating in a constrained world, constrained hardware, data, SGD. And I think that the transformer and ResNet have pieces that are generally quite important, and we will see them even in a new architecture. Even if, yeah, I think the part that I think is, missing is I am generally excited about adding searching and planning and blending that with the architectures. We're starting to see some initial work there. That's not a new architecture, but it's a blend of techniques to help the models reason better. I think those directions are interesting. Of course, there's multimodal models, but I think the models that we have today have a reason for the pieces, the components inside them. They work well. They're fast, and they can be optimized well under SGD.
네, 한국말로 질문하셔도 됩니다. 네, 동시 통역되고 있어서. 네, 다음 또 질문을 받아볼까요? 예, 바로 앞에.
한국말로 질문하겠습니다. 네, 반갑습니다. RSN의 김광수라고 하고요. 영어로.
네, 그럼 계속하십시오. Let me check. 오케이, 하시면 되겠습니다.
지금 되고 있나요? 반갑습니다. 네, RSN 김광수라고 하고요. 개인적으로 이제 그 스탠포드 강의에서 많이 뵈서 되게 친밀한데요. 제가 궁금한 게 그 트랜스포머와 지금 현재 LMM의 단점이라고 한다면은 그 데이터가 업데이트됐을 경우에 LMM을 전체 다시 학습을 해야 되는 맹점이 있는데 그러다 보니 컴퓨팅 비용이 많이 발생하는데 온라인 러닝과 같이 그런 기법을 활용한다면은 추가된 데이터만 추가 학습을 해서 비용을 절감할 수 있을 텐데요. 현재 트랜스포머 구조에서는 그게 어려울 것 같아서 만약에 그런 기술을 구현하려고 하면은 어떤 아이디어 방법으로 접근하는 것이 좋을까요?
Got it. This is great. This is great, by the way. That's a great question. So, to answer your question, why can't we continually train these models, right? With as you keep getting data, and we've been doing that. Google has been doing that for its recommender, for its search models. I think we can. But you have to keep in mind, you have to be sure that as you're doing it, you're not forgetting the capabilities that you learned with past data. So I think it's actually possible to update the models online. What will be important here is for you to actually measure what you care about and make sure that you're not losing the abilities as you update on new data. So if you heard about catastrophic forgetting, because when you train on new data, you might forget some knowledge or skills that you learned from previous data. And we've kind of seen this. Aaron, maybe you can confirm, but the base models have a different set of capabilities than the ones that are fine-tuned and the ones that undergo RLHF. So there is evidence that subsequent training does cause you to lose some abilities, and I think that having a way of actually capturing that effect and measuring it is going to be important, but I don't see a reason why you can't update these models. Now, there are other approaches to account for freshness, where the retrieval-based methods, where you retrieve information and then you put it inside the context, and then based on that, the model gives you answers, or model takes actions, and that's a popular approach today to account for freshness of data.
I'm actually curious. So is that true that you cannot? So let's say you finish the training, like say in 2021.
Yeah.
Is it what keeps us from like not being able to, right?
Nothing.
Okay.
I think it's just a question of, I think what we would have to do if there's some knowledge if there's some prior knowledge that we want to be maintained, we probably might add that data mixture. So I don't think that this is an impossible problem. I think we have to be careful about what we want to keep and what we are okay with losing. And that's a tricky question, yeah. Which also means evaluations are extremely important. People don't focus on evaluations. That's an incredibly important, both for deployment of these models for research and for product.
Thank you. And 또 질문 있으실까요? 오야, 저기 중간에.
I work with enterprise level data as opposed to public data. And if you can imagine a chart where the horizontal axis is the principle driven nature of the data, and the vertical is the depth of expert knowledge that needs to be going there. I think that the primary training modality for enterprise data may not be the same as the one for public data. What have you thought about that so far?
Yeah, and in fact, as I was sharing before, one point that I made was what we have to both measure and be aware of is that what skills can we transfer based on what we've learned in public data. If there's a large amount of knowledge that isn't in the weights of the models that is actually needed in the enterprise data, I don't think you have much of a choice there. You have to, the options are either you update the models based on that information, right? Or you put it in the context somehow with these retrieval methods. And I believe that the latter we haven't fully seen how successful that can be, right? Now, you asked another question, what about modalities? Maybe, and today these models are largely servicing text. They're very proficient at unstructured data and text, and to some extent images, right? What happens with structured data? Can we directly feed in numerical values and the models can generate trends? That would be a very exciting outcome, and enterprises have a tremendous amount of structured data. That's down the line. That's a research or that's a technical problem that we're particularly interested in. Can we just directly get trends from structured data? So I would say that the answer here is that what we believe in is working with enterprises and building solutions for them that that can leverage language models, because there might not be a match for some of the problems. So I was speaking to someone yesterday, they were excited in digital twins, and time series data is another very, very critical piece, but language models typically haven't been the star performers. They're improving over time, or transformers are improving over time. So there's some open questions there. But what's advantageous is that there's no, language models are the most general method we have today. You train it once, you train a large language models, and they can apply to many situations instead of building these verticalized products. I believe that tendency will still, we might still have that effect. And I also think that having the language component inside the model allows for people to interact and talk to the model. So I think that is another advantage that we, maybe if you take an existing open source model and adapt it to company data, we might still carry that. We will still carry that ability, the ability to understand human intent. Yeah.
네, 감사합니다. 한두 개 정도 더 할 수 있을 것 같은데요. 네. 예.
저쪽에 많이 손을 들었는데 우리가
정말
못 받은 것
죄송해요. 너무 멀어서 안 보였어요. 너무 멀었어요.
Very biased towards the right side. Yeah.
마이크가 가고 있어요?
네,
네.
들리실까요? 네. Thank you for being here. I'm really greatly honored to see the author of the Transformer. And I have a question about what you said in the previous talk that you made. Sorry about that. So while you were researching about the Transformer, I was wondering what was your main focus while studying, while researching on it? I mean, of course, it would be the state-of-the-art scoring. However, what else did you focus on?
Do you mean outside of the Transformer in general? Like is that your question, or was it that while we were building the Transformer, what are the other directions?
So you said for the Transformer, it said you made the unsupervising training, which really uprise the research area of the unsupervised learning. However, before they had autoencoders and GANs.
Yeah.
So what were your main focus when you started or conducted the research about Transformer?
Right. So some context here is helpful. When we started working on the Transformer, the incumbent were LSTMs, which were I believe one of the earliest Gen.AI models is Google Neural Machine Translation. It doesn't get enough credit, but it was a Gen.AI model. It was an encoder-decoder, and it was actually deployed, and people are using it, and using it successfully, right? So, but as you well know, LSTMs have an issue that they, when they read a sentence, they read one word at a time, and they also generate one word at a time. We haven't been able to escape generating autoregressively or one word at a time, but our goal at the time, at the beginning, it wasn't unsupervised learning as much as it was, hey, we should be able to read all at once. So we should be able to read the entire sentence. And attention is a very good mechanism for that. And attention should also be a good mechanism for generating kind of all at once and then iterating on it. So let's say you read English, you produce German, then you iterate on it, just like a bit like diffusion models. So that was our original goal. But till today, that general problem has not been solved. So then we switched to, all right, the architecture looks interesting. Why don't we try standard encoder-decoder? Because the advantage we still have is that we can read in parallel, so we can be much faster than LSTM. So that's how it progressed. After the Transformer, what was exciting to me personally was always this pursuit of the universal model. Can we have one model or one piece of software for all of machine learning? And so we immediately went into image generation. My co-author Nikki and my co-founder Nikki, co-founder and co-author Nikki, we built like the first state-of-the-art transformer model for image generation. I worked in music, and then computer vision as well. Wrote some of the earliest papers. So just the general excitement for me personally, Transformer and beyond, was how universal is this architecture?
Thank you. 이쪽에도 또 질문 있을까요? 마지막 질문일 것 같은데. 네. 저기 맨 뒤에.
Thank you for your contribution. And you have worked for very world-class research institute like Google Brain, and now you found a company. And then I'm curious about the biggest challenges or biggest lesson that you learn when you transform from research to the industry. Thank you.
So the reason why we even left research was because in many ways the future of these models was actually not, it wasn't in research anymore, because in order to make these models smarter, you needed to put them in people's hands, and then people would interact with these models, give it feedback, give it data, and the models would get smarter. They would get better at reasoning and planning and solving tasks, right? So that means you needed to build products, and as we know, it's very early stages. Building products from Gen.AI models, it's not a solved problem. There's many challenges there, but so on the technology side, it was how do you actually solve for the right problem for the user? That was an important. That's a puzzle. And second, I would say that this is separate of technology. It's when you build a company, is hiring is building the right team again. So today you're seeing 8 people here, right? And Google Brain was remarkable because you could breathe the rarefied air. There were incredible people there that you could brainstorm with and you could work together with to produce good work. And so that's been super important. And building a great team is top of mind for somebody who's building a company. So I would say that's been a great an important lesson. Building a team is so important.
Thank you. Probably the last question. 여기 한 분 계셨죠? 아니에요? Okay. Who? All right, good. This is really last question. Oh, up there.
Thank you very much for your presentation today. I would like to ask more about your company, Essential AI. I have read an article today from the Bloomberg that you have raised a fund of $40 million. So I would like to ask, what's your plan afterwards with your company? And I was also curious, why did you exit from Adept AI? Okay, so those two are my questions. Thank you.
I think most of this question should probably be answered not in person. So maybe we can address most of the question later. In particular, about I'm not going to comment on the article, and we should happy to chat about and maybe we can discuss what we were excited about at Adept and later. But what Essential is excited about, as I stated our mission is we want to help anybody in the company, from CEO to sales rep, to be able to ask any question of their data, any business question, and be able to get the answer. The model is able to help them get to the answer. Then that helps them make better decisions for the company and helps the company be more competitive. And in the future, we are actually looking to work with enterprises and co-develop build models for them and co-develop our product with them. That's what we're most excited about. And if you'd like to talk about Essential, potentially working at Essential, do reach out. I am here and I'd love to chat.